Okay, today we're talking about immunology. We know ology always means learning or study. So that means we're talking about our immunity. So immunity, that's basically we're talking about how to protections, people protection itself when they are with some pathogens, or with some microorganism, which is Finnish microorganism, including the virus, including the bacteria, including the fungi, and even parasites. So that's the people or even the animals, they naturally have these kind of functions to protect it of itself. These protected functions we use special words, immunity. So when we're talking about immunity, generally speaking, they can separate with two big parts or two big groups. One group we're talking about no special effect. No special effect. They still the way protected of ourselves. No special effect means any kind of pathogen evading, they will be against it. Not special for special kind of pathogen. So like any kind of bacteria, any kind of virus, or even any kind of fungi evading, they will be protected of self. That means no special effect. No special effect. Another category, we're talking about special effect immunity. That means they only working for a special kind of pathogen, like a special kind of virus, special kind of bacteria. So that like some immunity function, they can specially against pathogen A. Some special kind of immunity, they can special against for pathogen B. We can against a lot of different pathogens, but each of them, they may have specially, we talking about later, like antibody. One kind of antibody, specially working for one kind of special pathogen. Certainly inside of our body, we can have a lot of special kind of antibody. We still can against lot of pathogen. It not means specially only against one pathogen. We still can against lot of pathogen. But one kind of antibody only working for one kind of pathogen. Similar like the key relationship with the lock. One key working with one lock, but we can have a lot of key. We can working with a lot of lock. So that part we're talking about special effect. Special effect. So that's the general picture. General picture. So no special effect. No special. That's generally coming from naturally or just after birthing. And people naturally have this kind of immunity function. So it's not coming after birthing, naturally, just birthing. people will have this kind of function. So that's basically no special kind of immunity is the first line people against any kind of infecting pathogen. So that's basically. So what including in no special immunity function in there? So basically, somebody like something blocking there, protected pathogen couldn't invade it. We're talking about the first line of defenses against microorganisms. Something like our skin. We're talking about skin is the first line against the pathogen invading. But the skin is must be not broken. Yeah, it's connected and no injury and no broken. So that kind of skin truly protected of ourselves. And also the memories, yeah, mucosa memories. Like inside of our mouth cavity and inside of our nose cavity, they cover mucosa membranes. So that mucosa membranes still protected of ourselves. Like we talking about bacteria before, we talking about the normal flora. Lot of bacteria or other pathogens, they normally living like on the superficial of our skin, even inside of our mouth, inside of our nose. But they are usually not cause the illness. That's because we have skin protections, we have mucosa membrane protections in there. So that's two parts. Another part, inside the body, we have special kind of cells. We call it phagocytic cells. So that we talking about before, they have some eating functions. What they eat? They eating bacteria. They eating virus. They eating other pathogens. Or sometimes we even can call it eating cells. So these kind of cells is kind of category in there. They have different form, but they have the basic functions. We say they eating pathogens and then digest it. So that's a bacteria in here. That's the bacteria in here. And they looking like open the mouth to eat it. And then they will close here. Then when they go to inside the cells, like in here, that's still the pathogens. And they have special kind of admin can go to there. And the admin can digest the pathogens. So like coming from this side and gradually go to this side. So after digestion, you can see originally pathogen there is like a form of broken kind of shape in there. And finally release, go outside of the cells. So that's the process. These kind of special cells, they eating way or they kill the pathogen way. So that's including no specific kind of immunity. That's naturally like everyone naturally after birthing, they will have this no special kind of against the passenger way. That's our first line of our immunity. So we say physical, we have some way to protect it of ourselves. That's the first line, including the skin, including the mucosa membranes. That's pretty effective to protect it of ourselves. So that's basically the environments locally on the superficial of the skin is low moisture, low moisture, not too much water in there, and low pH. pH middle, we talked about pH before. Neutrally is 7. Low pH is less than 7. Less than 7. That means low pH. That kind of environment is not that easily for microorganism growing. So that's basically, that's basically. And we're talking about the low moisture. So that's we're talking about if too much water there, it's pretty easily for microorganism growing. Another things we need to be careful. We always talking about the hand hygiene. The hand hygiene, we always washing our hand. But after washing hand, make your hand dry. Not always keep it moist. So moistening kind of hand or skin still easily allow the microorganism growing. And also on our skin, superficial skin, we have some glands, like sweating glands. We have some other glands. The secretions is some like ingredients there. That kind of secretions still like inhibited microorganism growth. That's still kind of protection way. So that's mainly we talking about skin. But still possible, some like microorganism still possible go to inside of skin, like through the hair, through the hair. And we also have some glands. We also have some glands under the skin and sweating glands. They will have an open air. They always have open air to the superficial skin. So that way, some microorganisms still can go in and get infection locally. So that sometimes we can see local infection, like including the acne. Too oily there, and then some microorganisms go in, like bacteria go in. So still some way can go in, but usually they just cause the local problems, local infection. Then our body's immunity system will work in there and limited there, and finally relieve the infection there. And pretty similar like the skin, mucosa membranes. So they still protected our cell. In the superficial of the mucosa membranes is the epithelial cells in there. And under it is connected tissues. When we talking about the tissue before, we talking about we have two different kinds of tissue. In the mucosa area, we have epithelial tissue. So epithelial cells located, we say one is on the superficial of the skin. And they also cover internally superficial of the tube. So that means also protected. They're also protected. So internally, organ tube, including the digestion systems, including respiration systems, including urination system tube, and reproduction. So all the tube superficial it be covered with epithelial cells in there. So that's where in the no special family or immunity, we say we have the skin, we have the mucosa membranes, then we have others for some cells. We say these kind of cells, they have special functions. These special functions, we use a common use word, eating. Yeah. So they have eating function kind of cell. It's not only single cells in there. They are group of the cells. They have pretty similar functions in there. So in this group of the cells, yeah, we have neutrophil cells. Yeah, neutrophil. They have neutrophil cells. They have eating functions. Yeah, they have eating functions. So neutrophil cells is one kind of white blood cell. They are in our blood circulation, usually. Yeah. They have 5 different kinds in there. Yeah. So white blood cell including 5. Neutrophils is the biggest number there. Usually 70 to 80% of white blood cell is neutrophil. It's a big amount. Yeah. It truly producing very important protected for body function. So that's neutrophils. So neutrophils normally they circulation in the blood. Yeah, they circulation in the blood. But in some local area, got infections. We talk about the infections like a pathogen emitting. Then the neutrophils will coming from blood, moving to local infection area. If some students in our pathology class before, when we talking about inflammation, yeah, inflammation is local infection. And we got like acute one, we got blood vessels sterilized. And then lot of liquids go to locally. And some cells go to locally. The cells mainly neutrophil cells. So that's mainly, yeah, mainly. And we also have other cells yeah, naturally kill cells. So that basically belong to lymphatosis. Yeah, lymphatosis. So lymphatosis still can go to blood circulation. Still can be one kind of white blood cell. Lymphatosis, they have different shape. Yeah, different shape. Uh, one kind of shape like a little bit bigger, a little bit bigger. So these kind of lymphatosis, basically we give it a special name, natural kill cells. Sometimes we just call it NK. If you see the NK, means these kind of cells, NK cells. So these kind of cells functions, they still can go to kill some like a microorganism. They mainly working for virus. Yeah, virus infections. NK cells will go to there and kill them. Another function for the NK cells, they can kill some cells like they thinking about it sick cells. Like sometimes tumor cells. They can go to there and kill them. So that's the special function of the NK cells. And we also have locally in the lung. We know lung we call alveoli, yeah, smaller like unit in there. And we have special kind of cells in there also. Specially protected of our lung function. So lung is the open organ, respiration systems. We say they directly have like a respiration tract open to outside of our body. Yeah. So like people, that's the nose. Yeah. So air is pretty free to come in and go out. Like our lung is totally open to outside. Not like other organs, even like some other organs inside the body is not truly open to outside. So that means the lung is pretty easily got the passenger go in and infection there. So that we have special kind of cells in there. They're functionally pretty similar like the cells we talked about above. Yeah, neutrophils and NK cells. They can remove the passengers, or we say eating the passengers, and remove some sick cells. So that's a special protections for the lung. All of these cells here belong to the eating cells. All of them, they have eating passengers functions. When people getting sick or got pathogen invading, the cells will be working to kill them. So that's our part, no special effect. Yeah, no special. So we say our immunity systems, they protected of our bodies, they can separate with two big groups. Yeah, two big groups. The first group is no special for them. Yeah, no special for kind of immunity. These parts, including the physical protection, including the skin. Including the mucosal membrane. Yeah, that's physically blocking. And they also including the cells. The cells part is group kind of cells. Yeah, group kind of, they have eating function kind of cells. What do they eat? They eat pathogens like bacteria, like virus, and other pathogens. And they also can eat like some sick cells, like the tumors, and also some cells coming from other organisms, like the transplants. So certainly, usually we use transplants to treat people, but the big problems is our body is thinking about not cells. It's not belong to ourselves. They still kill them. We're talking about that part later. But generally right now, we're just thinking about these cells. They eating passenger or microorganisms, and they also eating the sick cells. So that's the part we're talking about. No special immunity function. Let's still go to a video first. Then we coming back, go to special for immunity.
Let's talking about immunology today. What is immunology? Immunology is the study of the immune system and is a very important branch of the medical and biological sciences. The immune system protects us from infection through various lines of defense. If the immune system is not functioning as it should, it can result in disease, such as autoimmunity, allergy, and cancer. It is also now becoming clear that immune responses contribute to the development of many common disorders not traditionally viewed as immunologic, including metabolic, cardiovascular, and neurodegenerative conditions such as Alzheimer's. The immune system. The immune system is a complex system of structures and processes that has evolved to protect us from disease. Molecular and cellular components make up the immune system. The function of these components is divided up into non-specific mechanisms, those which are innate to an organism, and responsive responses, which are adaptive to specific pathogens. Fundamental or classical immunology involves studying the components that make up the innate and adaptive immune system. Innate immunity is the first line of defense and is non-specific. That is, the responses are the same for all potential pathogens, no matter how different they may be. Innate immunity includes physical barriers, for example, skin, saliva, and cells, for example, macrophages, neutrophils, basophils, mast cells. These components are ready to go and protect an organism for the first few days of infection. In some cases, this is enough to clear the pathogen, but in other instances the first defense becomes overwhelmed and a second line of defense kicks in. Adaptive immunity is the second line of defense, which involves building up memory of encountered infections, so can mount an enhanced response specific to the pathogen or foreign substance. Adaptive immunity involves antibodies, which generally target foreign pathogens roaming free in the bloodstream. Also involved are T cells, which are directed especially towards pathogens that have colonized cells, and can directly kill infected cells or help control the antibody response. Immune dysfunction and clinical immunology. The immune system is a highly regulated and balanced system, and when the balance is disturbed, disease can result. Research in this area involves studying disease that is caused by immune system dysfunction. Much of this work has significance in the development of new therapies and treatments that can manage or cure the condition by altering the way the immune system is working or, in the case of vaccines, priming the immune system and boosting the immune reaction to specific pathogens. Immunodeficiency disorders involve problems with the immune system that impair its ability to mount an appropriate defense. As a result, these are almost always associated with severe infections that persist, recur or lead to complications, making these disorders severely debilitating and even fatal. There are two types of immunodeficiency disorders. Primary immunodeficiencies are typically present from birth, are generally hereditary, and are relatively rare. Such an example is common variable immunodeficiency. Secondary immunodeficiencies generally develop later in life and may result following an infection, as is the case with AIDS following HIV infection. Autoimmune diseases occur when the immune system attacks the body it is meant to protect. People suffering from autoimmune diseases have a defect that makes them unable to distinguish self from non-self or foreign molecules. The principles of immunology have provided a wide variety of laboratory tests for the detection of autoimmune diseases. Autoimmune diseases may be described as primary autoimmune diseases, like type 1 diabetes, which may be manifested from birth or during early life, or as secondary autoimmune diseases, which manifest later in life due to various factors. Rheumatoid arthritis and multiple sclerosis are thought to belong to this type of autoimmunity. Also, autoimmune diseases can be localized, such as Crohn's disease affecting the GI tract, or systemic, such as systemic lupus erythematosus, SLE. Allergies are hypersensitivity disorders that occur when the body's immune system reacts against harmless foreign substances, resulting in damage to the body's own tissues. Almost any substance can cause allergies and allergen, but most commonly, allergies arise after eating certain types of food, such as peanuts, or from inhaling airborne substances, such as pollen or dust. In allergic reactions, the body believes allergens are dangerous and immediately produces substances to attack them. This causes cells of the immune system to release potent chemicals like histamine, which causes inflammation and many of the symptoms associated with allergies. Immunology strives to understand what happens to the body during an allergic response, and the factors responsible for causing them. This should lead to better methods of diagnosing, preventing, and controlling allergic diseases. Asthma is a debilitating and sometimes fatal disease of the airways. It generally occurs when the immune system responds to inhaled particles from the air, and can lead to thickening of the airways in patients over time. It is a major cause of illness, and is particularly prevalent in children. In some cases it has an allergic component, however in a number of cases the origin is more complex and poorly understood. Cancer is a disease of abnormal and uncontrolled cell growth and proliferation, and is defined by a set of hallmarks, one of which is the capacity for cancer cells to avoid immune destruction. With the knowledge that evasion of the immune system can contribute to cancer, researchers have turned to manipulating the immune system to defeat cancer, immunotherapy. Cancer immunotherapy seeks to stimulate the immune system's innate powers to fight cancerous tissue, and has shown extraordinary promise as a new weapon in our arsenal against the disease. Other applications of immunological knowledge against cancer include the use of monoclonal antibodies, proteins that seek and directly bind to a specific target protein called an antigen. An example is Herceptin, which is a monoclonal antibody used to treat breast and stomach cancer. Moreover, a number of successful cancer vaccines have been developed, most notably the HPV vaccine. Transplants involve transferring cells, tissues or organs from a donor to a recipient. The most formidable barrier to transplants is the immune system's recognition of the transplanted organs as foreign. Understanding the mechanisms and clinical features of rejection is important in determining a diagnosis. Advising treatment and is critical for developing new strategies and drugs to manage transplants and limit the risk of rejection. Vaccines are agents that teach the body to recognize and defend itself against infections from harmful pathogens, such as bacteria, viruses, and parasites. Vaccines provide a sneak preview of a specific pathogen, which stimulates the body's immune system to prepare itself in the event that infection occurs. Vaccines contain a harmless element of the infectious agent that stimulate the immune system to mount a response, beginning with the production of antibodies. Cells responsive to the vaccine proliferate both in order to manufacture antibodies specific to the provoking agent and also to form memory cells. Upon encountering the infectious agent a second time, these memory cells are quickly able to deal with the threat by producing sufficient quantities of antibody. Pathogens inside the body are eventually destroyed, thereby thwarting further infection. Several infectious diseases including smallpox, measles, mumps, rubella, diphtheria, tetanus, whooping cough, tuberculosis, and polio are no longer a threat due to the successful application of vaccines. This is the basic knowledge of immunology.
So that's we're talking about the immunity functions or systems is protected of ourselves, including the passenger immunity, including if we body have some sick cells, they will be working. But it is like a relationship with some other issues, like it's not truly the sick or illness, like a transplant, they still can working, that may be effective. So we finished no special fake kind of immunity. Now we go to special fake kind of immunity. Yeah. No special kind of immunity, we say that's composed by the skin and the membranes and some special kind of cells. They are naturally everybody have, and they are against any kind of like a pathogen immunity, nothing special. Now we're moving to the part we're talking about specific. This is something special. The first aspect, the special things, is not like naturally people have it. They will have it after they birth it. Acquired. Yeah, acquired. So it is still the way we protect it of our body, still against the passengers, including the microorganisms and some others, like sick cells, they can form the cancer or tumor. But they are not naturally people have these functions. They must be have some specially like process recognized first and then remember it and then reactions. So that's basically our immunity systems is learning and then remember, then respond. So that's what they recognize. Usually, It's something special. Yes, something special. Special kind of stimulation. Usually we call it antigen. Usually we call it antigen. So these antigens can naturally have, when we're talking about people sick or illness, like some passenger emitting whatever microorganism, whatever is the bacteria or maybe the virus, invading of the people, and then people getting sick. After they're getting sick, our immunity systems will start working. Certainly, no special kind of immunity will go to there and against it, and also special kind of immunity will go to there also. But special kind of immunity, there have some process. They must be recognized it first, and then they can work it. So they come in there, they recognize first. So that's usually they know it after it recover. And when people have the same, we say special kind of immunity. It's especially like a one-to-one kind of working. It must be the same pathogen evading. Second time, first time they just recognize, and the second time evading, still the same pathogen. Then they can against it. So that's it specialized here. Recognize first, then remember. These kind of pathogen gave me sick or illness already. So when it's second time coming, it will be immediately reactions. So that's we're talking about specific kind of immunity. They have special kind of memory there. For special. That's the most case. That's the most case. Later on, we will talking about vaccine. Vaccine, we go to the similar way. Similar way. We say people often naturally get the sick, get positive evading. They will trigger or special kind of immunity functions like recognize, then remember, then response, and then second time immediately reaction there. So how about like we use some way, make it immediately reactions when we got this pathogen evading. So that's the scientists and the doctors thinking about many years, and then they find we can use some way naturally, like use some way, take something from the passengers, like a bacterial virus. So we try to figure out, like in which part of bacteria or which part of virus or immunity systems can recognize. It usually in the superficial, whatever bacteria or virus, they have some special kind of protein in there. Then our immunity system can recognize. So how about we just take this part, like antigen, and then trigger our immunity system, got some recognize in there, and got some memory there. And then next time the pathogen evading, they will be immediately reactions. So after working for many years, like we look the video when we first class, we talked about the first vaccine, yeah, especially for chickenpox. Yeah. They just take some, like we say, it's better when we take the lice, will be more safety for people. But for bacteria, maybe well, that be easily. We just take some like a memory part, including some special kind of protein in there. But for the virus sometimes let be hard to take this apart. And also for some bacteria, still that be hard only to take some part and trigger our immunity systems reactions. So what we do? Sometimes we still possible use the whole bacteria or maybe the whole virus, but we try to reducing their toxins in some way, maybe chemical way or maybe physical way, reducing their toxins. Sometimes we may use the diet, yeah, we kill them, yeah. The died bacteria or virus, sometimes the died virus or bacteria not working that well. We still can use the live virus or bacteria, but just decrease their toxins. Then give to the people. Yeah. Can orally use, can like injections. It's depending what kind of like passages. Yeah. We go to different way, yeah, different way. And we go to decrease toxin kind of passenger or even died passenger, even part of the passenger, like a protein in there, and trigger our immunity systems recognize. So in this kind of case, the second time patient meeting this kind of pathogen, they will have immunity reactions immediately. So thus we do vaccine. So that's basically we say special kind of immunity function. They can come in from naturally, like after people getting sick. They also possible coming from after vaccine. So we say especially immunity, they have some process need memory and recall. And especially for exactly the same reactions when it happens. So that's the specialty. So that's why. So because we have this kind of specially or acquired immunity, like our immunity have learning functions. So that's a lot of illness. Like we only getting once. We are not getting second time because we have this kind of special kind of immunity. And also we're talking about this special kind of immunity also possible coming from like a vaccine. That means after people got the vaccine, they may not got the same illness anymore. So that's basically how the special kind of immunity, how it working. Special kind of immunity still can separate with two different way or different part. One part we call active way. One part we call passive way. So that's basically we're talking about special immunity. And they can be natural way, or they can be like made by the people, like a vaccine. Then we go to positive immunity first. What means positive? Positive means we use antibody directly. That means positive. And so antibodies, natural way, we say both positive and active, they have both ways. One is natural way, one is artificial way. Negative way means the people itself can producing antibody and then can protect it. So that's basically, if the same person, we're talking about same person, like we talked about before, first infections and then recognized and remembers and then reactions. Certainly in the reaction part, there's antibody working. But this way not truly cause the positive. It still cause the active because it is still triggered by the antigen. So what kind of situation we say that belong to naturally positive way? That's basically the antibody transforming from mom to the fetus. So for the fetus, it directly got antibody. So the antibody is not producing by the fetus. It just received from the mom. So like directly receive antibody. That's the way immunity we call positive. So positive immunity means directly receive antibody from others, from other people. The natural way that usually happens between the mom and the fetus, and between the mom and the new baby with the feeding the baby. That can coming from the milk, That's usually coming from the first few months. After a few months, it's not that big amount of milk contains antibody anymore. Just the first few months. And coming from the mom to the fetus is kind of blood circulation. Blood circulation from the mom to the fetus. So that's the natural way positive kind of immunity. it only happens between the mom to the centers, or maybe between the mom and the new baby. Then we're talking about artificial way. Yeah, artificial way. So still directly receive antibody, like people getting sick. We say special kind of sick, we need a special kind of antibody. Like passenger A, yeah, passenger A, they need a special kind of passenger A antibody to against it. But the special kind of antibody, they only happens when certain time people got infections. We don't expect it. People always get sick. Like after first sick, then second sick, then they got protection. We try to protect it the first time. So like people getting sick immediately, we got the antibody to against it. So where the antibody coming from? Right now we can producing some antibody from some animals. And we also can take some antibody from other people. They getting sick and give this kind of antibody to the patient. Typically, we're still talking about COVID-19 is so popular right now. So we say when people recover after COVID-19, and some people truly can donate it blood. So inside it blood, they will contain the special kind of antibody. That special kind of antibody can against COVID-19. So that's we say can come from other people if they have antibody already, can give other people getting the same sick, same illness, can get prevention, or even treatment. So that's we talking about positive immunity. Then we're talking about active immunity. What means active immunity? Active immunity means we use antigen to trigger our immunity systems to get reactions, like we talking about the process before. Recognize first, then remember, and then second time infection immediately, working. Certainly, first time they still working, but this small amount is a little bit slow. When the second time, its reaction pretty faster. It's a big amount antibody coming immediately, and immediately against the same pathogen. So still, active kind of immunity still separate with natural way, or artificial way. Natural way is basically naturally people getting sick, infection or sick, and then they can trigger the immunity systems, get recognized and remember, and reaction, like a triple R in here for you easily remember. That's the natural way. Natural way. So basically, like all the illness, after people get infections, they will trigger immunity systems, get active kind of immunity. That's the trigger. Then we're talking about artificial way. That's basically what we're talking about, vaccines. So we make some antigens artificially. Like we talking about, we can use part of the bacteria or part of virus, or maybe the whole bacteria or whole virus, but we kill it. Or even we couldn't totally kill it. We just decrease the toxins of it. Like we make some bacteria get a patient look like it will be trigger for some special kind of illness. But because the passenger mostly like the part or the diet is not truly cause the illness, they just trigger the immunity systems reaction. But truly for some special kind of virus, if we totally cure it, it will not truly trigger immunity systems reactions. So in that kind of case, we just use the decreased kind of toxin kind of virus and then give people like immunity trigger reaction. So that's like when we talk about virus before, we talk about some special kind of vaccine. If they use live kind of virus, even we decrease the toxin already, but still not use for or be careful use for people have immunity function disorder, like AIDS kind of patient, or maybe pregnancy kind of woman. Because for the AIDS kind of patient, their immunity function very, very low. Even just a small amount decrease toxin kind of virus, if they will give this kind of patient, they still possible cause the patient illness. So we are not use that kind of vaccine called give this kind of patient. And also for pregnancy, also for pregnancy. So let's go to positive kind of immunity there. We say antibody can passing through the plasmid, like blood circulation goes to the baby. And certainly some virus, also possible from the mom go to the baby or go to the fetus. So certainly mom immunity usually still okay if they are pregnancy. But if this kind of life kind of virus go to the mom, they possible passing through to the fetus. Fetus immunity truly pretty low. So we are not using live kind of vaccine go to immunity deficiency kind of patient. So that's we say artificially way we use antigen directly using for the patient and then trigger our immunity systems reactions. So recognize, remember, and the second time when we meet same like same kind of pathogen, they will immediately react. So this way, we call it active kind of immunity. So the difference, positive kind of immunity and active kind of immunity. We say positive kind of immunity, they like reactions is immediately. Immediately. Because antibody is immediately against the pathogen. There are immediate reactions. But the antibody, we say whatever naturally, they still coming from the mom. It's not produced by itself. Or artificially, it's coming from animals or other people. They keep the time pretty short. That's the special kind of protein. Special kind of protein. They usually just stay in the blood circulations, maybe just a few days or 10 days, but usually pretty short time. Like after few months, people got the same illness, same pathogen infection, they will not working anymore. So you still reuse the antibody. Reuse the antibody. It's not like a lifetime kind of protection, but their reactions is pretty faster. That's the positive. Active kind of immunity is look like take a little bit longer time. We need to process for 3R in here. But it is lifetime protection. Lifetime protection. Whatever is people naturally get the sick or ill, got active kind of immunity, or even artificially. When they trigger the immunity system, got reactions, recognize, remember, and reactions. They will be whole life, lifetime protection. So that's the difference between positive immunity and active immunity. They work in different way, but they both protected of our body against the pathogen. So that's about special kind of immunity, including positive and active. They could be have positive way and negative way. This page. So special kind of immunity could be active, could be positive. And they both could be naturally and could be artificially. So any question in this part?